Hello, this is Mrs. Taylor, and I am going to demonstrate how to solve a linear equation that involves proportions. So a proportion is a statement where two ratios are equal, and ratios can also be called fractions. In my example here, I have a fraction equal to a fraction, so officially we can call that a proportion. What you learned in middle school is to solve a proportion, you cross multiply. So what that looks like is I take diagonally a numerator and a denominator and I multiply them together. Now that you've learned the distributive property, you are prepared to do this because you would have to multiply the 1 times the c and the 11. So what we do is we write that as 1, and then in parentheses we put c plus 11. And that represents the fact that I have to multiply those together. I do the same thing with the other diagonal here. One denominator, one numerator. And so what that looks like is 3 times c plus 19. And I use parentheses to demonstrate that operation. Now, the question is, what goes between these two products? Well, this equal sign is still a true relationship because when you cross multiply in a proportion, the products are still equal. So all I need between these is an equal sign. Once I've done that step, this looks a lot like what we've been practicing with multi-step equations. I now have to distribute and then solve. So what I would do is I would first distribute the 3 into the parentheses on the left side of the equal sign. The result would be 3 times c, which is 3c, and 3 times 19, which may take a minute with the calculator. So 3 times 19, 57. So plus, because it's positive 57. I do the same thing on the right side. I distribute the 1 to both terms in the parentheses. So 1 times c is c, 1 times 11 is 11. And again, what do I put between them? Well, this relationship is still equivalent, so put an equal sign between them. Now it's a multi-step equation with the variable on both sides. And so whether I solve this using my calculator, looking at the table or the graph, or if I solve it algebraically, I should still get the same result no matter what my method. I'm going to demonstrate how to solve it algebraically. And technically, just if I wanted to, I could have put a 1 in front of this c as a placeholder. You're welcome to do that. And I'm going to do that because that'll make the rest of my work easier. What I know is that my c terms need to be brought together. And since I need to cross over this invisible barrier of the equal sign, then I need to do the opposite operation. So if I want to move this 1c to the side with the 3c, once it crosses over, it becomes the opposite sign. The other way I can think about that is it's a positive 1c, so if I want to get rid or eliminate it from this right side, I would need to subtract 1c. And so whatever I do on the right side, I have to do the left, because remember, an equation is it's like a scale, it's balanced. Whatever I put on one side, got to put on the other. And so what happens when I do 1c minus 1c, that equals 0, and so they kind of just disappear. And all I'm left on this right side is an 11. We should still have that equal sign. On the left side, I've got some cleaning up to do. So I need to figure out what 3c minus 1c is. Well, 3 minus 1 is 2, and then we've learned that when we combine like terms, we work with the coefficients, and then we just carry the variable with our answer. 3 minus 1 is 2, and that C would stick with that 2. And then this plus 57 would just be brought down. At this point, what I've done is simplified down to where I just have a two-step equation. This is very familiar. So, plus 57, I would need to undo that by doing the inverse, which would be to subtract 57. Remember, whatever I do to one side, gotta do to the other. So 57 and negative 57 equals 0, and they disappear, and I'm left with a 2c on the left side. And then on this right side, I need to figure out what 11 minus 57 is. That's one that I could do in my head, but I don't feel very confident. So 11 minus 57, type it in the calculator, and I get negative 46. At this point, I now just have a one-step equation. It's 2 times c, and I want to isolate the variable, so I need to undo the multiplication. The way I undo the multiplication is use the inverse operation, which is division. And what we've learned is division is just a fraction. So what I create is a fraction with the 2 on the bottom, but whatever I do on one side, gotta do to the other. On the left side, 2 divided by 2 is just 1, and 1 times c is just c. Negative 46 divided by 2, again, that's one I could do in my head, but I'm going to check my work, my mental math, by a calculator. So negative 46 divided by 2 is negative 23. Now, feeling pretty confident I did my steps correctly, but I'm going to check my work. What I need to do is I need to take this negative 23, and if that is indeed the solution, if I substitute it for c in my original, I should get a true statement. So that first substitution would look like this. I'm going to label this checking my answer. So I would have 1 over negative 23 plus 19. Remember, when we substitute, we always use parentheses. And then on the right, I'd have 3 over negative 23 plus 11. Now there's nothing to distribute into these parentheses, so technically they can just disappear, and I can do negative 23 plus 19. And then on the right side, I can do negative 23 plus 11. Once I find those sums from adding, I get 1 over negative 4 equals 3 over negative 12. Now if you're quick with your fractions, you may recognize that 3 over 12 does reduce to 1/4. If you do not, you just do 1 divided by negative 4, get that decimal, which is negative 0.25 or negative 0.25. And then if you do 3 divided by negative 12, you also get negative 0.25. And so because I get a true statement, the left side does in fact equal the right side. This solution checks out, and I can put it as my final answer. So that's how you solve equations with proportions.